Hi guys, in the previous lesson we dealt with linear pattern and exponential. We now come to quadratic.
And Nelson, this is one of the most exciting of all the number
I know
patterns.
that is your baby.
Absolutely. You've got to watch this. There's some beautiful techniques in here. If we carry on, a quadratic number pattern is a number pattern with a second constant difference, or a constant second difference. If we have a look at this one, 8, 18, 30, 44. Let's look at this number pattern. There it is. Now, guys, it's not going to be linear. You're not going to get a constant difference
or
exponential. Now, Nelson, what is happening with this number pattern? Do you want to take them through this? Let's have a look and see what is going on in this pattern.
18, 30, 44, 60. What I always do, Margaret, I always start with subtraction. Let's find if we can find the difference here. Right. 18 minus 8 is 10. 30 minus 18 is 12. If I keep on finding the differences here, I will get 10, 12, 14, and 16. And it's not constant. So it doesn't take the name of linear.
In fact, that row is called the first difference row.
Yeah.
In fact, that first difference row is a linear pattern.
Yeah.
But it's not linear for the original.
The whole sequence is not linear.
Yes.
Okay.
So let's see what happens.
If we carry on, this is first difference, as Mike said. Now, we carry on in finding the second difference. It's 2. 12 minus 10, 2. All these differences will be 2.
Isn't that amazing? A constant second difference.
Yeah.
Isn't that amazing? Let's see what we get there.
And then we call this second difference.
And this becomes what we call a quadratic number pattern. Okay, so let's see what happens now if we carry on.
Right. This 8, 10, 2.
Now, important, guys, circle the first term of the first difference row and the constant second difference. Now, there's a very important thing I want to show you.
All the first terms, okay.
Okay, now people look at this. The guy 2, the second difference, I'm going to call 2a. The 10 is 3a plus b, and that is a plus b plus c. Now, if you remember this, okay, there are proofs for this thing, but we're just going to go straight into it. Think about this. A boy meets a girl. Nelson meets a hot girl and goes out for dinner. And they're sitting and they're having coffee at a coffee shop. Nelson and the boy and the girl are together. And it's amorous. It's romantic. Then suddenly what happens is I come along. And I say to Nelson, "How you, brah? How's things going?" Notice, what do they say in English? They say, 2's a company, but 3's a crowd. So the moment you started with 2a, now you've got 3a plus b. 3a is bad. If there's 3 people there, it's bad. Nelson can't get to talk to his girlfriend because I'm there. That's bad. And then the girl gets totally upset and they all have a big fight and they separate and they go A plus B plus C. So look at this. So
I like
2a,
this analogy, Mark.
Yeah, 3a plus b and a plus b plus c. And then what do we know? We can say 2a is 2, 3a plus b is 10, and a plus b plus c is, of course, 8 there. Now we've got that there. That's so important. 2a, 3a plus b, and a plus b plus c.
And I think, Mark, we do have other methods, but we prefer this to the other methods, guys.
Absolutely.
Just work on our method here.
And it's in the national memos. I remember that they actually keep this in, which is so exciting. It's such a nice way. 2a's, Nelson and girlfriend. Mark comes along, 3a plus b, bad. And then we've got a plus b plus c. So let's see. What we can do is we say 2a is 2, so a is 1. Now you've got 3a plus b equals 10. Now replace the a with 1, and then b is 7 if you take it across. A plus b plus c is equal to 8. So we know a and b already, and there we go. So c is equal to 0. Then we've got the general term of a quadratic is, do you want to tell them, Nelson, what is the general term for quadratic?
All right. General term, we have a n squared plus b n plus c.
Absolutely.
And guys, do not stop here. You must write this down. Okay. A is 1, b is 7, and c is 0. Replace it.
Very important. So there it is. And then we can simplify it as Tn is equal to n squared plus 7n. Now that's a quadratic. It's almost like it's a quadratic. If you drew the graph, it's a parabola, which is quite nice. And now we can use this formula to work out the 20th term. 20 squared plus 7 times 20. There we go. Nelson is going to be 540. So remember, when we're dealing with this thing, what are we dealing with? it's quadratic. You get a first difference row,
Yeah.
which is linear. Then what do we get? Is we get a constant second difference, okay? And then the important thing is 2a. That's so important. 2a. 2a is going to be Nelson and girlfriend. 2a, they're getting amorous, okay? Then I come along and I say, Nelson, bro, how's the soccer going? And of course, Nelson, I like soccer, so that's a problem. So it's 3a, and that's bad. 3a plus b. And then, of course, the girlfriend says, Nelson, I am sick and tired of
this
you
Mark.
and Mark. Always talking about soccer. And then what happens?
A
It
plus
goes
B
A plus B
plus
plus
C.
C. They are just totally unlike each other. They hate each other. They're not going to get involved there. So what happens is you get that. And remember, always start at the bottom. 2a is equal to the thing. 3a plus b and a plus b plus c. So guys, hold on to this. It's very, very important. We're going to continue with number patterns in the next part of this lesson. Stay with us. It's good having you with us. See you soon.
See you.